So this is section 6.5, operations with radical expressions, and it's kind of like a continuation of what we've been doing already. Let's take a look at the notes. We all already know this right here, okay? We should know this right here. We know that you could have any root of whatever base to whatever power, and you could rewrite it as a rational exponent. What is a rational exponent? It's an exponent that's really a fraction, okay? So any root of any base to whatever power could be rewritten as that same base with an exponent that's a fraction, and that fraction is power over root. Okay? So we should be able to do this guy right here with that knowledge. And even if you don't have that knowledge, you could still rewrite cube roots as the power of 1/3 and work it out with math, right? So you don't have to memorize the power over root thing, but it will help you out. So what's the first thing to do on simplifying any type of radical? It doesn't matter if it's a cube root, fifth root, any type of radical. What do you do first when it's like this? Anybody? So whenever you have pure multiplication, no addition or subtraction, pure multiplication, you're able to split that root. It doesn't matter what kind of root it is, you could split it to each one. And it's kind of like having four simple problems. Let's look at this first one right here, the cube root of 54. Now, it's not a square root, it's a cube root. Back when we had square roots, we would like a perfect square number. Right here we have cube roots, so we would like a perfect cube number. It would be awesome if this were a 64, because the cube root of 64 is 4. But it's not 64, it's 54. So the question is, could I rewrite this with multiplication to get a perfect cube number? Now, if you're like, well, I don't know my perfect cube numbers, let's just, how about this? Let's get the first perfect cube number. What's 2 times 2 times 2? 8. Okay, so that's a perfect cube number. Could I rewrite 54 as 8 times something? No, it doesn't work. Right? 8 times 7 is 56. Didn't work. What's the next perfect cube number after 8? 27. So maybe 27 will work. Will 27 times something give me 54? Yeah. 27 times 2 will give me 54. So now we're going to split that cube root. And because we have this cube root of a perfect cube number 27, we could get an actual answer, 3. And of course, the cube root of 2, you're just going to bring that down. The cube root of 2, you don't mess with it. It's already simplified. Now, this next one, if you remember these notes from above, you're going to remember that whatever power you have here, you want it to be over the root. So technically, you want it to be divisible by that root. Because remember, it's power divided by root, and that's an exponent. So if you know that, you'll be able to look at this guy right here and say, oh, 6 over 3, 6 divided by 3, what's my answer going to be? X squared, right? A 2 as an exponent. But let's say you forgot, all right? Let's say you don't remember that. Well, you at least remember that a cube root could be rewritten as a power of 1/3, and on the inside you'd have x to the 6th. And then you should remember, based on the rules of exponents, that a power to a power, you multiply 6 times 1/3, that will give you that 2 that you got down there anyway. So the notes from above, it helps you out. That way you don't have to show that work, and you could just think power over root, 6 divided by 3 is 2. Okay. Again, the idea is if you have a third root, you want something that's divisible by 3. Okay, and 6 is divisible by 3. That's why it works out so beautifully. Now, 14 is not divisible by 3. Okay, so I want a power that's divisible by 3. So what should I do if I don't have 14 is not divisible by 3? I want to rewrite this with multiplication. What should I rewrite it as? Y to the 12th, that's right, times y to the 2nd. Because y to the 12th times y to the 2nd is technically y to the 14th. But of course, we're going to split that cube root to each of those. And now we know that the cube root of y to the 12th is what? Y to the 4th, right? Power over root. 12 is divisible by 3, it's 4. And then this one you can't do, so just bring it down. The cube root of y squared. And how about that last one? What is the cube root of z to the 3rd? That's just z to the 1. Or just z, right? Because remember, power over root 3 divided by 3 is simply 1. So you're going to write z to the 1, or obviously just z. You don't need to put that 1 up there as a power. You could have even thought of this logically. What undoes a third root, the third power? It undoes itself and it'll just leave you z. Anyways, this is our answer, but we need to write it nicely. What do I mean by nicely? Anything that's still in a root, let's put all of those values together underneath that one root. So I'm going to take the third root of 2 and the third root of y squared, and I'm going to write that as the third root of 2y squared, putting the roots together. And then everything else that did not have a root, everything that's on the outside, the 3, the x squared, the y to the 4th, and the z, I'm just going to write it out here. 3 x squared, y to the 4th, z. And this is my final answer right there. Fun stuff, right? So this is something that we should already have the skill to do, simplifying radicals. Now, in addition to simplifying radicals, today's section is adding, subtracting, multiplying, dividing radicals. Okay? So let's begin with adding and subtracting radicals. And it is very similar to pre-algebra. What do I mean by that? 2x plus 3x is 5x. We could add or we could combine like terms, right? If I had a 2x plus 3y, I wouldn't be able to add it, right? They have to be like terms in order to add them. So with radicals, it's the same idea. Right here I have 2 of these square roots of 3's. Then I have 3 more of these square roots of 3's. So what's my answer going to be? 5 of those square roots of 3's. So obviously, if I had like 2 square root of 3 plus 3 square root of 5, then I wouldn't be able to add those. I just can't do it because they're not alike. Okay? So keep that in mind. Adding radicals is the same thing as pre-algebra, adding like terms, combining like terms. Okay? So when we take a look at this one down here, these are not like terms. I cannot say 5 take away 2. I can't do that because they're not, it's not like I got like 5x here and like 2y over here. I can't really do it. Well, at least not yet. Because what I need to do is simplify whatever I could simplify. You see, the square root of 8, it's not a perfect square number. I could rewrite that to become what?
9 times 2.
On the 18, yes, 9 times 2. Well, right here on the 8, I'm going to rewrite it as 4 times 2. That way, when I split the root, I could actually do the square root of 4, which is just 2, and the square root of 2 comes down. Are you with me? Now, let's not forget about this outside 5. What sign is between the 5 and the square root of 8? What sign is right here? There's multiplication, right? There is no sign, which means multiplication. So I really have this multiplication of 5 that's out in the front. So I need to put that multiplication of 5 out in the front of my answer. So what do I really have here? I have 5 times 2 times the square root of 2. It's all pure multiplication. Might as well multiply 5 times 2. 5 times 2 is 10. And what about that square root of 2? It's just going to stay right there. So what do I have here? I have 10 square root of 2. Let's simplify this guy, and hopefully we end up with the square root of 2 also, so I could actually subtract them. Okay? So I am going to subtract. I'm going to put a minus sign right here. But let's figure out what this is. It's a 2 times square root of 18, but the square root of 18, I could rewrite it as what? 9 times 2. And we're going to split that root, and the square root of 9 becomes 3, and the square root of 2 stays the square root of 2. And again, don't forget about this outside multiplication of 2. Bring that down, outside multiplication of 2. And of course, 2 times 3 is 6 with that square root of 2. That comes down. Are you with me? So this whole first thing became 10 square root of 2. This whole second thing became 6 square root of 2. I have a minus sign between it. What's my final answer going to be now? There you go. 4 square roots of 2. I had 10 of these guys. I'm taking away 6 of those same guys. I end up with 4 of those guys. So that's adding and subtracting. You want like terms. Now, similar to pre-algebra, when we multiplied like 2x times 3y, you don't need them to be like terms. You don't need x's to multiply with x's. I mean, you can say 2x times 3y. What's the answer? It's 2 times 3 is 6, and x times y is exactly that, xy, x times y. So you don't need like terms when you are multiplying. So right here, Yes, I could simplify the square to 8, but I don't really need to, at least not yet. I could just multiply the radicals with the radicals and the numbers with the numbers. After all, this does say 2 times the square root of 2 times 3 times the square root of 8. So I'm just going to rearrange it. 2 times 3 times square root of 2 times square root of 8. 2 times 3 is 6. And we could put these guys together, square root of 16. But what is the square root of 16? So I really have 6 times 4, which is final answer. What? Yeah, 24. You guys are asleep. Oh yeah, we're getting to the fun stuff here. Fun stuff. Number 2, fun stuff. A binomial times a binomial, but they're not the same binomial, right? We got to distribute, we got to combine like terms. Let's do it. Check it out. 3 times 2 is 6. 3 times negative square root of 10. That's kind of like saying 3 times negative x. The answer should be negative 3x. But instead of negative 3x, we have square roots of 10. So negative 3 square roots of 10. You with me? How about this next one? Positive square root of 2 times 2. That's like saying positive x times 2. It's going to be positive 2x. But instead of x, you have those square roots of 2. And then you got positive square root of 2 times negative square root of 10. A positive times a negative is a negative. And the square root of 2 times square root of 10, we could actually do that. What do we get? Square root of 20. That's right. And could I combine these middle terms? Could I combine the negative 3 square root of 10 plus 2 square root of 2? No, I can't. Can't do it. Because they're not like terms. You got like a x right here and a y over here. They're different terms. If this were a square root of 2, then yeah, for sure I could combine the negative 3 square root of 2 with the positive 2 square root of 2. But they're different radicals. So they're different terms. I cannot add or subtract them. What about that square root of 20? Well, it's not simplified, so let's at least simplify it. I could rewrite 20 as 4 times 5 and then split the root. Then I'll get 2 square root of 5 with a minus sign in front of it. Did that help me? Not really. But, I mean, we got to do this anyway, because if you had like a square root of 5 over here, then you'd be able to combine that one with this one, if you had a square root of 5. But all the radicals are different. That must mean that that is our answer. Our answer is 6 minus 3 square root of 10 plus 2 square root of 2 minus 2 square root of 5. I know that's crazy, but that is your answer. How does that taste? Tastes good, huh?
I feel like you can you like this juice?
Yeah, there's nothing to do here. I mean, I would like, yeah, it's weird to get an answer this long, especially if there's no variables. But yeah, that's the answer right there. This next one, does anybody like want to say a certain word when you see this? Easy? Okay, but I'm talking about a vocab word from the past. Starts with a C. You got it. What is it? Conjugate. Conjugate. What? Conjugate. What is a conjugate? It's a binomial, same binomial, but they have that middle term is different. And when you multiply a binomial with its conjugate, it's a beautiful answer, right? It'll get rid of the square root. It'll get rid of imaginary values if you had imaginary values in there. Let me show you. When you're multiplying a binomial with its conjugate, 3 times 3 is 9. 3 times square root of 7 is positive 3 square root of 7. Then you got negative square root of 7 times 3. That's a negative 3 square root of 7. Then you got negative square root of 7 times positive square root of 7. That's negative square root of, what's 7 times 7? It's 49. But watch the magic happen. The middle terms are always going to eliminate because one's always going to be positive. They're always going to be opposite. And then the last term, that square root of 49, actually becomes a regular 7 with a minus sign in front of it. And what about this 9 over here? Just put the 9 right in front. And 9 take away 7 is 2. Okay? What do you think? Cool? Now, this is very important. It's gonna surface many times. Now, let me tell you this. I'm going to show you right now how to do this mentally, okay? Since you know that whenever you multiply a binomial with its conjugate, the middle terms always cancel out, okay? The middle terms always cancel out. Then all you really need is the first term and the last term. So what you could do is simply get that first term by going 3 times 3, write down the 9, and then get the last term by multiplying the last ones. The -7 and the negative square root of 7 and the positive square root of 7, that'll give you a negative square root of 49. Then you got the -7, and the 9 take away 7 is 2. It even works when you don't have radicals. Like, think about this. What if I said multiply, let's say x minus 3, x plus 3. Well, what's first term times first term? X squared. You know the middle terms are going to cancel out. So what's the last term times the last term? -9, right? And that's it. You don't really have to do the whole thing and combine like terms because the middle terms will always cancel out. That's just a little trick. Of course, you'll get there after doing all this work so many times. You'll get to that shortcut. Oh, just the first ones and the last ones, the middle terms cancel out. Let's go to the top right corner of this handout. We have some previous notes from section 6.4. Now, we've already talked about this. We've already done this. I just wrote them again here to show you that, yes, you could split a square root when you're multiplying, or you could put them back together, right? You could put them back together. Like if you have the square root of 8 and the square root of 2, you can put them back together, and it'll become square root of 16, which will give you 4. We already know this, but I wanted to show it again because we didn't do much division, but it's the same exact rules as multiplication. You could take that single square root here and split it to your numerator and the denominator. Or you could go backwards where you have them separate and you could put them back together underneath one square root. Okay? Here's an example of when it's nice to split, right? It's the square root of 9/25. That sounds crazy. But if you split it, square root of 9 is 3, square root of 25 is 5. The answer is 3/5. Super easy. Or you may have two separate square roots and you could actually put them together if it benefits you. Right here it does. 8 divided by 2 is 4 and the square root of 4 is 2. So you could split the root apart, or you could put the roots back together, depending on what's better for you. Okay? Now, the one thing about dividing radicals is that you don't want to leave a radical in the denominator. So you might want to highlight this or underline this. One thing we must always remember is to not leave the radical in the denominator. You do not want to leave a radical in the denominator. So if you ever do have a square root in the denominator, you could get rid of it by simply multiplying it with itself. Okay? So check this out. I could get rid of this square root of 3 by multiplying by itself, that same square root of 3. But of course, on a fraction, whatever you do to the denominator, you have to do to the numerator. The reason for that is the square root of 3 over the square root of 3 is really a 1. So if you're multiplying something by 1, it doesn't change it. Okay, that's why you have to do both top and bottom. But anyway, what is the square root of 3 times the square root of 3? That is the square root of 9, which takes you back to 3. And what about up here? What is 1 times square root of 3? That's just 1 square root of 3. So there's your answer, 1 square root of 3. Another way of writing it is to split it up and put like 1/3 times the square root of 3. Or even another way of writing it is to just erase this 1 and leave it square root of 3 over 3. Okay? All of these are perfectly acceptable answers. Again, the goal is to not have a radical in the denominator. Okay? You know what? I want to give you a different angle at this exact question. 1 over the square root of 3. 1 over 3 to the 1/2 power, since square root is really the power of 1/2. Now, why am I doing this? Because next week we're going to get into getting rid of rational exponents in the denominator, because rational exponents are radicals anyway. And the way to think about it here would be to multiply with the same base but to a certain power in order to make it whole. All right? Right here you have 1/2. And remember, rule 1 of exponents, when you are multiplying with the same base, what do you do with the exponents? You add them, you combine them. So 1/2 plus what fraction will make it one whole? 1/2 plus what fraction will make it one whole? Come on, people. Time to wake up. 1/2 plus what fraction will make it one whole? You got half a pizza. How much more do you need to make a whole pizza? Another half. Wow. It's like pulling teeth. All right. So we can multiply both top and bottom by that 3 to the 1/2 power. And of course, add these two together and you will get 3 to the 1 on the bottom. And up on top you have 3 to the 1/2. But then again, you don't need a power of 1 in the denominator, so you could just write that as 3. And of course, you could rewrite this back to a radical square root of 3. So square root of 3 over 3 is your answer. I know you're thinking, why the heck would I want to do that when I already know if I have a square root of 3 down there, I might as well just multiply by the square root of 3, and that gets it done quickly. Now, the reason why is because next week, we might have, let's say, 3 to the 3/5 power down here. Imagine that, 3/5. So what would you need to make it whole if you had a 3/5 right here? What would you need to make it whole? 3/5 right here. What do you need to make it whole? 2/5, right? So you'd have to multiply both top and bottom by 3 to the 2/5. That's in the future. I just wanted to give you a slight little taste right now. That way it'll become easier for you next week when we actually get there. But for right now, when you have a single square root in the denominator, simply multiply both top and bottom by that same square root, and it'll get rid of the square root. Now, the only other detail is, what if you have a binomial in the denominator that has a root? Simply multiplying by the square root of 2 is not going to cut it, because you have a binomial down here. And if you just multiply by the square root of 2, you technically have to distribute to both, and you're going to end up with another square root. It doesn't get rid of it. So what would I have to multiply by to get rid of all square roots? The conjugate, exactly right. Now, what is the conjugate? 3 minus square root of 2. And of course, we're going to multiply both top and bottom by that same conjugate value, 3 minus square root of 2. And it's like doing two separate problems. I'm going to go for the top one first. Top one says 2 times 3, that's 6. 2 times negative square root of 2, what's the answer there? Negative 2 square root of 2, right? Now for the bottom, I already know that multiplying a binomial with its conjugate, I already know the middle terms are going to cancel out. Could anybody do this math in their head and tell me what the denominator is going to be? I know that the middle terms will cancel out, but the first ones won't. That'll give me a what? 9. The last ones won't either. What will that give me? A positive square root of 2 times negative square root of 2. Negative square root of 4. And what is negative square root of 4? Negative 2, right? Or yeah, minus 2. So you really have 9 take away 2, which is 7. I'm just showing you that you will, after practicing this so much, you will be able to do that in your head if you want. If you don't, let's just show our work the way we always do. Check it out. Here we go. 3 times 3 is 9. 3 times negative square root of 2 is negative 3 square root of 2. Positive square root of 2 times 3 is positive 3 square root of 2. Positive square root of 2 times negative square root of 2 is negative square root of 4. And like we said, whenever you multiply a binomial with its conjugate, the middle terms always cancel out. They're always opposite of each other. You have 9, you have the minus sign, and you have the square root of 4, which is really 2, which gives you 7 in the denominator. And there's your answer. Now, how do you guys feel about that? Yeah? I got some sad news. Sad news is, all these problems that we just did, you could get the Casio calculator that I have at my desk. You could type it in, and it'll do it for you. What? Then why the heck did you teach? No, okay. Well, the truth is, we're not going to have all numbers. Like right here, all these numbers, the Casio calculator will do it. But if you look at the worksheet on the backside, we have some of these that don't have pure numbers, like number 33. It's a great example, especially to follow up with the one we just did, right? So the Casio calculator cannot do this one. So let's all learn how to do this one together. It's challenging, it's fun, I know. What do I need to do to get rid of that square root in the denominator? Multiply by the conjugate, okay? So what is the conjugate? It's 2 plus square root of x. Both top and bottom, 2 plus square root of x. So we have to do both. Which one should we do first? The top ones or the bottom ones? Top? Okay, so the top ones, we have 3 times 2, that's 6. We have 3 times square root of x, that's positive 3 square root of x. We have positive square root of x times 2, that's a positive 2 square root of x. Then we have that positive square root of x times positive square root of x, that's positive square root of what? X squared, right? Now, the middle terms do not eliminate, but we could combine positive 3 of those square roots of x with positive 2 of those square roots of x, and what will I get? Positive 5 of those square roots of x, positive. Thank you. And of course, the 6 is in the front, and in the back, we have plus, what is the square root of x squared? That's just x. So there's my answer for the numerator, this guy right here. Let me write it over here. 6 plus 5 square root of x plus x all by itself right there. That is the numerator. Now for the denominator, again, when you multiply a binomial with its conjugate, that magic happens, that the middle terms cancel out and the roots disappear. Does anybody know what the answer is just off the top of your head? 4 minus x. You got it. Dang. 4 minus x. Now, if you don't get it, that's okay. Let's keep doing the work. You'll get it eventually. Let's show the work here. 2 times 2 is 4. 2 times x, square root of x, is 2 square root of x. Negative square root of x times positive 2 is negative 2 square root of x. Negative square root of x times positive square root of x is negative square root of x squared. And yes, the middle terms will always be opposite. They will always eliminate. The square root of x squared, the square root and the square eliminate. I will have a minus x, and I'll have this 4 over here in the front. So 4 minus x is our denominator. Fun stuff, right? Anyways, is there anything else that we could cancel out or combine? Nope, it's done. That's it. This is your final answer right here. You cannot cancel out the x's because there's a plus and a minus involved. The only way things could cancel is if it were pure multiplication, okay? I would also like to say, if you did not have a binomial right here, if it was just a square root of x, you could just multiply both top and bottom by that square root value. But when it's a binomial, you have to multiply by its conjugate the way we did right here. Now, if you look at the worksheet, I recommend practicing, even though the calculator can do this for you. I would practice by multiplying both top and bottom by the conjugate, square root of 5 plus 2, right? Working it through. But in reality, the calculator could do any of these except these guys over here, like number 14, like number 10, like number 15. All those down there, the calculator cannot do it. So it'd be a good idea to practice those, all those that have a variable in it. Would you guys like to see any of those? All right, you guys want to see 13? That one is entertaining. Oh my gosh. Let's start with what do you do when you have a square root on something that has pure multiplication and division on the inside? You could split it up to each term, right? So let's start with that. And then we're going to tackle each one of these individually. The middle one's easy. The third one's kind of easy. This first one, that's kind of entertaining. Let's jump into this. What are we going to do right here? Split the root. Why would I split the root? Because the square root of 1 is 1. Now what about the square root of 128? That'd be nice if it were a perfect square number. If this were a 144, the answer would be 12 right here. But it's not 144. If it were 121, that'd be an 11, because 121 is a perfect square number. The problem is 128 is not a perfect square number. So I need to simplify the square root of 128. I need a perfect square number. So I would take this big number and try dividing it by 2 and seeing if that's a perfect square number. If it doesn't work, maybe try dividing it by 3 and see if that's a perfect square number, and so on and so on. So 128 divided by 2, what is that? Is 64 a perfect square number? Yeah. Yes, it is. So I'm going to rewrite 128 as 64 times 2. And I'm going to split the root. And the square root of 64 is 8, and the square root of 2 is the square root of 2. So instead of this square root of 128, I'm going to have 8 square root of 2. So far I have 1 over 8 square root of 2. Now there's a problem with this. The problem is that we have a square root in the denominator. Now if this were a binomial, like 8 plus square root of 2, that I would multiply by the conjugate, 8 minus square root of 2. But it's not 8 plus square root of 2. So I'm not going to be messing with conjugates here. I just want to get rid of that square root in the denominator. So what would I have to multiply by? The actual same square root of 2 value, both top and bottom. Okay? So when I multiply, 1 times the square root of 2 is just going to be 1 square root of 2. You don't really need the 1. I'm going to leave it there. And how about the square root of 2 times square root of 2? What's that? Square root of 4. And what's square root of 4? 2. So I really have 8 times 2, which is what? 16. So this first part, oh man, this first part, the whole thing equals 1 square root of 2 over 16. You know what? Let me write it bigger. And not only that, I'm going to separate it. I want to put 1/16 and then square root of 2 separately. Okay? Because at the end of it all, you want the square roots together and whatever is on the outside of the square root out in front of it. Let's jump to our second term right here, the square root of c to the fourth. What's the square root of c to the fourth? C to the second, right? Do I have to show my work? Or are you guys cool? You're cool? All right, cool. Again, a square root is a power of 1/2, power to a power multiply, or you could have thought power over root. 4 divided by 2 is 2. Right here, 7 divided by 2 doesn't work. I want something divisible by 2. So I need to rewrite this as what? D to the 6 times 1 more d. And of course, we're going to split that root. And now I could say the square root of d to the 6. What's my answer there? D to the third. And the square root of d is simply going to stay the square root of d. So I have these 3 separate answers that I need to put together. So how's this going to work? We're going to put everything that's on the outside of the root in front of the root and everything that's on the inside of the root together underneath one root. So I'm going to take this square root of 2 and this square root of d and put it as the square root of 2d. And then I want to take the 1/16 out here in the front. I want to take the c squared. I want to take the d to the third. And there's my final answer. 1/16 c squared d to the third square root of 2d. I know what you're thinking. Man, I can't believe this entertainment is free. Like you're not even paying any money for this, right? Amazing. Should we try another, or you guys want to practice on your own? Yes.
Are there going to be a lot of questions like this one?
Maybe not. I mean, this requires a lot of steps. I'll probably ask shorter questions, but you still need to know all this info, you know.